Hi, welcome to GPU Solutions. In today's video, we have this Palit RTX 3060 Ti, and it is reported as not getting detected. So let's go ahead and check what exactly is wrong with it, and let's try and fix it. So to start off, let's measure the resistance on the PCIe. Let's start off with the 12 volts, and we have kilo ohms and rising. So we don't have any shorts over here. Let's check the 3.3 volts. And we don't have any shorts over here either. Okay, so let's check the 8 pin, 12 volt 8 pin. And it doesn't look like we have any short here. No shorts. Okay, so looks okay. So let's connect the power supply and let's see how much voltage it's getting pulled. Turning on the power supply now. And as you can see, it's only drawing 0.03 amps, which is very low. So probably some of the voltages are missing. Here you can see the voltage of the amps that is getting drawn. And so some of the voltages inside are missing. So let's go ahead and disassemble this card and see the PCB inside. Okay, so I have gone ahead and dismantled the GPU and connected my power supply. And let's start measuring the voltages on the inner rails. Maybe we have something missing. So we'll start off with the 8 pin, 12 volt 8 pin, and we have 12 volts. So our 12 volt is present. Let's check. This is memory. So let's check memory. And we have nothing on the memory. Let's check 1.8 volts. We have nothing on the 1.8 volts. Let's check 5 volts. We have nothing on the 5 volt either. Okay, let's check at the back. So we have this 12 volt that's coming in from the back. Let's check that. And we have 12 volts coming in from the PCIe. So we have the 12 volts that's coming in from the PCIe and the 8 pin, but something is not right. We don't have 5 volt that's present. So something is dropping off somewhere, and let's find out. So let's get under the microscope and take a closer look. So something is dropping off from here. So we have all the three rails all together, the 12 volt PCIe, we have the 1.8 and the 5 volt all clustered together. And we have the 5 volt missing. So if the 5 volt is missing, none of the other voltages will be present. So let's start off investigating from the 5 volt. And this is a 5 volt and we have nothing. So let's take a look at the 12 volt that's coming into the 5 volt. And we don't have 12 volts coming in. And that's the cause of the problem. So since the 12 volt is not coming in, we will not have 5 volt. So let's take a look at this pin. Nothing. Let's check here. Nothing. So I think this is ground, but yeah. So our 12 volt is missing on the 5 volt IC, and because of that, we will not have 5 volts, and we will not have any other voltages. So the 5 volt initiates, or it activates when the 12 volts on the PCIe as well as the 12 volt on the 8 pin is present. So if one of the two is not passing through, the 5 volt will not be activated. So let's check, on the under the microscope if we can find anything that is out of place or which is not normal or burnt or something like that. Maybe we can identify. Let's take a look at the MOSFETs. There's nothing obvious that I can see here. This particular resistor looks a little bit discolored, and the same on these ones as well. Okay, so let's take a look here. Let's check if we have 12 volts here. We have nothing. So 12 volts is not coming into this resistor. We should be getting 12 volts here, and but we are getting 12 volts on the inductor. So the voltage is coming in through the inductor, and then it goes on to the back of the PCB, and then it travels its way back to the front through this resistor here, and we have no voltage that's coming in through the resistor. So something is wrong at probably at the back when the voltage, because the voltage is passing through the inductor. The voltage is there, but it's not coming in. Let's take a look over here. We don't have anything that's coming in thereafter. So something is wrong. We might have to take a look at the back, but we'll just check if there's anything else that we can find. Let's move to the back. Okay, so this is our circuit. This is how the voltage passes through, and it comes to the front. It goes through this shunt here, and I can see something broken. Looks like our trace is broken here. Yeah. So because we had that, the mask still over it, we couldn't see it properly, but now we can actually see that this trace is completely into half. So it's completely broken, and that's why we don't have 12 volts going on to the 5-volt line. And normally this occurs when there is a short circuit. It's a known fault with the 3060 Ti's. But I never knew that something like this happened with a Palit. It's used to happen with Zotac, but this is the first time I'm seeing it on a Palit. So definitely there was high current that was passed through, because the resistors are completely discolored, and I don't see any. Yeah, I can see. You can see that there is a short. There's a short circuit on this side of the line, but if I measure this side, it's normal. So we have to find out where that short circuit is, and that's the cause of the problem. Normally, the capacitors which normally short are somewhere here, but I don't see any capacitors here. On Zotac, you find the capacitors over there. So this side is also shorted, so that means our resistor is okay, but it's discolored. You can even see the shunt resistor that it's discolored. So the 12 volts comes in and passes through to this weir, and then it goes through the front, and it comes into this particular resistor here, this one, and then it passes through over here. But we don't have any inductors, or probably it's supplying voltage to some other part of the circuit. And we can see we have a short here. Let's take a look at PEX. Let's see if the resistance on the PEX is okay. Yeah, it looks fine. Let's take a look at the resistance on the memory. So this is the circuit. This is where the 12 volt comes in. And yeah, you can see the short. But our memory looks okay. This is Hynix, and I think the resistance is a bit low. So, but we will find out later on, because Hynix has a very bad reputation with its memory on the GDDR6, but this is not the X005, so this is SC2. I think this should be okay. And as you can see, we don't have a short on the rest of the circuit, but we do have a short that's coming in. So could it be one of the MOSFETs that's been shorted, or could it be the capacitors? We don't know. We'll have to find out. But it could be, it might be possible that one of these MOSFETs have shorted. And you can see, I can just scrape off the paint from this resistor. So you can imagine the kind of current that it may have drawn from, causing this kind of damage on the board. So this, I think this is just dirt, but yeah, something is wrong with the memory rail. I still wonder at this point if our GPU core is still okay, because a short on the memory rail would mean there is more damage, and the 30 series are not known to survive if there is a short on the, on the memory side. But we don't have short on the memory rail itself, but it's that the 12 volt that is powering it, it powers the memory rail, and looks like that side is connected to the memory. So let's go ahead and connect a wire. I suspect either the memory, sorry, or either the MOSFET or the capacitors are shorted, either one of the two. So let's go ahead and prepare and connect the wire. So I'll just add some flux. So I'm going to inject voltage. So I'll just tin this resistor. So this is where I'm going to connect the wire to inject the voltage to the memory rail. Not exactly to the memory rail, but the 12 volt side. Because the MOSFETs that turn on the memory rail do require 12 volts as VCC. So without the 12 volts, it will not power or it will not turn on. So let me connect the wire. You can see that it's not holding on proper solder on the resistor, but let's try and connect. I think, yeah, I think that should be good enough. It looks secure. It's not moving. Okay, so time to inject the voltage. Let's inject voltage. I'm injecting 1.5 volts and 5 amps. Let's see what heats up. Turning it on now. There you go. It looks like a capacitor is shorted. It's not the MOSFET, so it's the capacitor that's shorted. Let me turn it on again, just to be sure. Yes, it's the capacitor that's shorted. And you can clearly see, let me point it out. Yeah, it's warm. Okay, so it's this particular capacitor that's shorted. So I'm just going to take this one off, and then we're going to measure the resistance. Let me apply some flux and prepare it. I will first tin it, so it's easier for me to remove this capacitor, because I don't want to use hot air. And the thing here is that Hynix memory modules are very, uh, well, they don't last with too much heat. So you have to be very careful when it comes to Hynix. They don't like heat. So I'm just going to use my iron to take this thing off. Okay, so first let's go ahead and check if our short is gone. We have removed that capacitor. Let's measure the resistance and see if the short is gone. Let's measure here. And you can see that the short is gone. It's now kilo ohms and rising. Let's take a look at the back as well. Let's be absolutely sure. Let's check the wire. Yeah, there you go. So it's high resistance and we no longer have a short. So it was the shorted capacitor and we've taken it off. So let's go ahead and remove the wire. Let's take this thing off. Okay, so we'll need some more flux. Let's add some flux. And let's try to give it some touch-ups. I think that should be okay. Oh, there you go. Okay, that looks much better. Okay, so next is we have to find a donor capacitor because I don't have stock of those capacitors with me. I'll have to find it on a donor board. So let's take one from here. This is a donor board. It's a 3060 Ti, same Palit 3060 Ti. We can take one from here. Let me take the capacitors off, just one, just the capacitor, one capacitor. And we are going to transfer it over on to the other board. Okay, so let's go ahead and install this capacitor now. So I'm just going to place it over and with one of the sides, I'm going to attach it first. I'm just going to tin or just melt this portion here. It already has leaded solder on it, so I'm just going to touch it. And with the other side, let me come in with the second iron. And just like that. So solder on both the sides have melted, so it's going to fall in place. And yeah, there you go. So I'm just going to clean this portion here. So it looks a little bit untidy with all that burnt flux on it. Let me just clean it a bit. So I'm just going to put some paper towel down and brush this thing off with isopropyl alcohol. So if you're wondering, the isopropyl alcohol that I'm using is 99.9%. And I'm just going to brush it over with a normal toothbrush. To just get rid of all the black burnt flux that was left over after installing the capacitor. Okay, it looks much better. Let's blow the isopropyl alcohol. Okay, let's measure it again. And as you can see, we no longer have a short circuit. Okay, so the short is gone. We fixed the short. The next thing is to fix this trace here. And we have to join this trace, but instead of just joining the trace, I'm going to add a fuse. So I'm just going to make some modifications here so that I can add some safety to the board because this board doesn't have any fuses. And if it blows again, it's going to blow out completely. So I'm just going to add a 10 amp fuse, not a big one. Just a 10 amp is enough for a 3060 Ti, and I'm just going to have to make some provisions here to add the fuse. And yeah, I think this is going to fit. This is going to be good enough. So I'll just have to clean off that uh, solder there and measure which one connects where. So I'll just cut this portion out because we don't need that portion extending it into the fuse. So because I don't want it to touch the other side. Let's check here. Let's measure. So this is not connected. Okay, it looks like this is connected. Okay, so I'm just going to remove this solder here. I'm just going to clean this portion, make it flat because I'm going to then go ahead and put some mask on it just to cover it. So I will just wick this portion out. I'll just mix leaded solder so that it's easier for me to wick it out. So there you go. I think that's good enough. Let me, yeah. Now let's go ahead and wick it out. There you go. So I'm not pressing it too hard. I'm just gliding it over. And yeah, so all the solder is out. Let's clean it off completely. Make sure it's completely clean because when I apply the mask, I don't want any residue of the flux being left over. So I'm just going to clean it with isopropyl alcohol again. Okay, so this looks much better. So now let me apply some solder mask and cover this portion up. So things that are not required, I'm going to cover it now. Okay, so that looks like it's hardened. Let's drill this portion out and expose some copper because one side of the fuse is going to get installed over here. So just going to expose some of the copper and tin this portion up. Okay, that looks good enough. Let me just brush this dirt off because I don't want it to be on the board. Let's clean this off. I think it's sticking, so let's use isopropyl, clean it off. There you go. Looks much better. Now let's add some flux and tin the exposed copper. Looks much better now. Okay, so I'm just going to add some leaded solder onto the exposed copper and the shunt resistor. I think that's good enough, but this resistor, the surface area is much larger, so it will take some more heat to get some solder onto the resistor. Okay, let's get in a resistor. Let's position the resistor and see how we can best adjust it on, to install it. So this is just a 10 amp resistor. Let's place it over here. I think that should be good enough. So I just have to make sure that this fuse doesn't make contact with the memory there because just at the side I have the capacitor for the memory. I think that should be good enough. It's not making contact. There is enough of space around. So yeah, that's good enough. And I'm just going to add solder on this side. I think, yeah, okay, I would need some more flux. Let's add in some more flux. And now let's add in the solder. So we're just going to bridge this portion. I think that should be good enough. Let's clean this flux off. So this is just a cotton pad that I'm using to brush off the flux. And as you can see, all the flux is coming off now. And a little bit more work, and the flux should be off completely. I just want to make sure that whatever work that I do is nice and clean. There's no residue or anything that's left behind. There's still some flux here. Let's see how best we can get this flux removed. No, it's still there. Let me just brush it off directly. I think it looks better now. Let me use isopropyl alcohol. Okay, it looks much better now, and it doesn't look part of the circuit, but that's the modification that we had to do just to safeguard this GPU, from failing or burning and any trace out again. Okay, let's blow this thing out. It looks nice and clean now. Okay, so now the 12 volt is getting passed on through this fuse, and this fuse is going to safeguard for anything or any misfortunes that happen in the future. So our resistance is normal, so we don't have any short anymore. We have replaced the faulty capacitor that was shorted, and we've also added a fuse where the trace had broken. So this resistor looks fine to me, so there's no need to replace them. They are 0 ohm resistors, and they look absolutely fine to me. No need to replace them, even though they look the paint has come off, but it's fine. So let's go ahead and power it on. And as you can see, it's drawing about 1 amp, which is looking good. Let's check the memory rail first. And we have 1.3 volts. That's good. Let's check PEX. We have PEX. Let's check our 5 volts. And we have 5 volts. Let's check 1.8 volt. We have 1.8 volt. So most of the voltages that are required, we have it all. I suspect we also have the phase. That's the reason we have the 1.8. Let's put this onto a test bench and power it on and take a look. Okay, so it's on our test bench. Let's put this thing up. Let's see if the card now gets detected and if we have any image. Waiting. We do. So we have an image. So let's go ahead and clean this board up and assemble it for stress test. And there you go. As you can see, our GPU is now running stress tests and doing the benchmarks. So yeah, so once this benchmarks are complete, it's going to go back to its rightful owner. So I hope you learned something from this video. It was a very detailed video. I showed every step and my entire thought process of doing it. If you liked it, please hit the like button and don't forget to subscribe for more content like this. If you want to support the channel, you can always use the thanks button as a one-time option or join in as a member. Your contribution helps. If you have any questions, don't forget to leave them in the comment section and I'll make sure that I answer them for you. So thank you for watching. You have a good day. Bye for now. Cheers.